Okay, Algebra 2, these are the notes for 4.6 using the quadratic formula and the discriminant. Now, for the most part, this should be review from Algebra 1. You did do the quadratic formula in Algebra 1. The quadratic formula is used to solve any quadratic equation. So we've learned about different ways to solve by completing the square, by factoring, by taking the square root, and those forms work sometimes, but the quadratic formula works all the time. Okay, so this says the solutions of a quadratic equation of the form ax squared plus bx plus c equals 0, where a cannot equal 0, are given by the following formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a, b, and c are the coefficients from the quadratic equation, and you're going to plug those into the quadratic formula where they belong. Now the plus or minus is there because at the very end we're going to have two answers. Once we're going to use the plus and one time we're going to use the minus. So as we're working through these, I would go step by step just like I'm doing. Don't try to plug it into the calculator all in one step or you're going to mess up. Okay, so example 1 says to solve this equation by using the quadratic formula. So in order to use the quadratic formula, first thing I need to do is move everything to one side. Because if you noticed in that statement at the very beginning, it said ax squared plus bx plus c equals 0. So we have to have our equation set equal to 0. So what we will need to do is subtract 33 on both sides of our equation. Now, on the left-hand side, I'm going to have x squared minus 8x minus 33 equals 0. So now that my equation is on the left-hand side set equal to 0, we're going to talk about the coefficients for the quadratic equation that we're going to plug into the formula. So we need an a, b, and a c for our formula. So the coefficients ax squared plus bx plus c are the coefficients in this equation. So for a, that's always the number in front of x squared. In this case, that would be a 1 in front of x squared. In front of b, which is the x, the coefficient is negative 8. And then c is the constant by itself is negative 33. Okay, so I'm going to go ahead and write the quadratic formula down. My suggestion is every time you're working one of these problems, go ahead and write the formula down. If you don't have it memorized, this is going to help you memorize it because every time you write it down, it's going to help you remember. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so after I write down the formula, I'm going to start and plug in the numbers a, b, and c into this equation where they belong. So x is going to equal, my b is negative 8, so it's negative 8. And I wouldn't change that to a positive until the next step. Keep it negative b as is. Plus or minus the square root of, and I draw my square root pretty far down, and then b squared is going to be negative 8 squared minus 4 times 1 times negative 33. I didn't leave very much room here, so minus 4 times 1 times negative 33. Okay, and then this is going to be all over 2 times a, which is 1. Okay, first step is always just plugging it into the equation. Then we're going to start simplifying just a piece at a time. Okay, so what I've done is I've just copied my last step there and I gave myself some more room to work this out. So x equals, I'm going to start by simplifying just a little bit at a time here. So the double negative is going to change to a positive 8. Plus or minus the square root of. So underneath the radical here, I'm going to do negative 8 squared, which is 64. And then I'm going to go ahead and do negative 4 times 1 times negative 33. So that's going to be positive 132. And then all over 2 times 1, which is 2. Okay, now this next step that I'm going to do is underneath the radical, I'm going to add 64 and 132. So this is going to be 8 plus or minus the square root of 196 all over 2. Okay, so next step I'm going to take the square root of 196, and that happens to be 14. Now, if this wasn't a perfect square, I'll show you in a second, we'll do another problem where we will either need to simplify the radical or you may wind up with a decimal answer, depends on what the directions say. So I'm going to say x equals 8 plus or minus, since the square root of 196 is 14, all over 2. So now this is where we can separate it into two problems, and we're going to do x equals 8 plus 14 and then divide by 2. We're also going to do 8 minus 14 divided by 2. So when I do 8 plus 14 is 22 divided by 2. And we know that 22 divided by 2 is 11. Then I'm going to do 8 minus 14, which is negative 6, divided by 2, which is negative 3. Okay, so my two solutions for this equation are positive 11 and negative 3. What this means is if I was to graph this function, it would cross the x-axis at positive 11 and negative 3. These are the solutions, the zeros, the roots, the x-intercepts, all of those mean the same thing here. Okay, so example 2, I have x squared minus 34x plus 289 equals 0. So this one, we already have a 0 on the right-hand side. I'm actually ready to go for the formula. So I still like to write. Okay, so example 2, we've got x squared minus 34x plus 289 equals 0. So this time they already have a 0 on the right-hand side. So we can go ahead and write down what our a, b, and c are. So a is equal to 1. That's the coefficient of x squared. B will be a negative 34, and C is 289. Okay, so I'm going to write down the formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so once I've written my formula, I'm going to plug in those values. So x is equal to a negative 34 plus or minus the square root of negative 34 squared minus 4 times a times c. So that's 1 times 289. Make sure you extend your radical all the way across. Everything is divided by 2a, which is 2 times 1. Okay, so now I'm going to go through and start simplifying. So x equals, I'm going to change my double negative to a positive 34 plus or minus the square root of. I'm going to do negative 34 squared, which is 1156. Then I'm going to do 4 times 1 times 289. That's going to be minus 1156. Continue your square root all over 2. Okay, so you can see underneath the radical 1156 minus 1156 is going to cancel, so that cancels out my radical as well. So then all I'm going to have is that x is equal to 34. The plus or minus doesn't have anything after it anymore, so I don't need that, all over 2. So that means x is equal to 34 divided by 2, which is 17. So in this case, we just have one solution for this quadratic equation. What this means is this graph just goes down and touches 17 and either goes back up, or it's going up and touches 17 and goes back down. It just touches at that one point. Okay, example 3, we have x squared minus 6x plus 2 equals 0. We're going to use the quadratic formula again. It's already set equal to 0, so that's nice. My a is equal to 1, b is negative 6, and c is positive 2. And I realize it's going to get old hearing this over and over again. It does get old writing it over and over again, but eventually you'll have it memorized. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to go ahead and plug it in first. X equals a negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 2 all over 2 times 1. Okay, so x is going to equal, double negative is going to change to a positive 6 plus or minus the square root of negative 6 squared is going to be positive 36. And then 4 times 1 times 2 will be minus 8. All over 2 times 1, which is 2. Okay, so I just copied that last step so I could continue working. So now x is going to equal 6 plus or minus, we're going to do 36 minus 8 is 28, so that's still the square root of 28 all over 2. So this is the case where the square root of 28 is not a perfect square, so we're going to have to simplify that radical. So out to the side over here, I'm going to factor 28, remember using the L method. So I know that 2 goes into 28 14 times, and I know that 2 goes into 14 7 times. And remember, I told you if you have pairs of numbers, the pairs come out as 1, the leftovers will stay inside. So back over here to my problem. So I'm going to write x equals 6 plus or minus, and since there was a pair of 2's, I'm going to do 2 times the square root of 7. The leftover stays inside, and this is all over 2. Now what I can do is I can split this up and reduce the fractions. So I could actually say 6 over 2 plus or minus 2 square root 7 all over 2. So then I know that 6 over 2 is equal to 3 plus or minus 2 over 2 is going to reduce and cancel, so this would just be the square root of 7. Now, if the problem said to approximate the roots and to round, then we could type this into our calculator, and we would do 3 plus the square root of 7, which is about 5.6. And then I would do 3 minus the square root of 7, which is 0.4. And it depends on what the direction said if you're rounding to the nearest 10 or 100. So if it says to give an exact answer, then 3 plus or minus the square root of 7. If it said to approximate, then you can round. Okay, example 4 says x squared plus 13 equals 6x. So make sure that you move everything to the left-hand side. So this would become x squared minus 6x plus 13 equals 0. Okay, so I'm going to go ahead and write the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if I plug in, x is going to equal a negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13. Make sure to keep your radical all the way across, all over 2 times 1. Okay, so this is going to be x is equal to positive 6 plus or minus the square root of 36, and then 4 times 13 is 52, so that'll be minus 52 all over 2 times 1, which is 2. Okay, so now we're going to simplify underneath the radical. So I'm going to write everything else the same. X is equal to 6 plus or minus the square root of 36 minus 52 is a negative 16 all over 2. So at this point, I see the negative underneath the radical. That should remind me of imaginary numbers from section 4. So this is going to be 6 plus or minus. I know when I see a negative underneath the radical, that's going to bring an I on the outside. And I know that the square root of 16 is 4. So this will be 4i all over 2. I'm going to go ahead and split this up and say x is equal to 6 over 2 plus or minus 4i over 2 so that I can reduce my fractions. So we know that 6 divided by 2 is 3, plus or minus 4i divided by 2 is going to be 2i. So in this case, since this is an imaginary number, we're going to leave it just like this, 3 plus 2i. We can't do anything else with that. So remember, anytime you have a negative underneath the radical, that's going to bring an I outside and then continue from there. Okay, so this picture is just showing you the different values that you can get from the discriminant of the quadratic equation. The discriminant is the value that's underneath the radical, b squared minus 4ac. If you just calculate the discriminant, then that will tell you what type of root or solution there is, how many there are they real, are they irrational, are they imaginary, that sort of thing. So let me walk through this table and explain it. So the first one says if b squared minus 4ac is greater than 0. So if it is a positive number and the value is a perfect square, then you have two real rational roots. What that means is two real numbers, and the numbers could be written as a fraction. If b squared minus 4ac is greater than 0, which means it's positive, but it is not a perfect square, then the roots are two real numbers, but they are irrational. So that means there would be a radical in the answer, or you would not be able to simplify it into a fraction. If when you solve b squared minus 4ac it is equal to 0 exactly, then you have one real rational root. So that means there's one place on the graph that touches, and it is a real number that can be written as a fraction. If b squared minus 4ac is less than 0, that would mean that it's an imaginary number or complex root. Okay, so on example 5, it says find the value of the discriminant for this equation and describe the number and type of roots for the equation. So we are only going to do the discriminant, which is b squared minus 4ac, and we're going to look at that value and determine what type of solution there would be based on that chart. So for our numbers that we have here, our b is 3, so that's going to be 3 squared minus 4 times 1 times 5. So this is going to be 9 minus 4 times 5, which is 20. So we know that 9 minus 20 is going to be a negative number. So that's negative 11. So from that chart earlier, we said that if it's a negative number, when it's less than 0, that means that it is a complex root or a complex solution. So there are 2 roots here, but they are complex. Or that's another word for imaginary. Okay, one last example here. Find the value of the discriminant and describe the number and type of roots. So here, if I do b squared minus 4ac, so this time it's going to be negative 11 squared minus 4 times 1 times 10. So I know that negative 11 squared is 121. I know that 4 times 10 is 40. So 121 minus 40 is going to equal 81. 81 is a positive number. 81 is also a perfect square. So since it is positive and a perfect square, there are going to be 2 rational real roots. Okay, so you need to know how to use the quadratic formula to solve these quadratic equations, and then also use the discriminant to be able to determine what type of solution it is.